In this unit, I'm going to discuss wave behaviors, the first of which I'll talk about is reflection. I'll be covering two major types of wave behaviors. First, interactions between waves and other objects, and second, interactions between waves. Reflection is an interaction between a wave and an object. The most common idea about reflection is what you see in a mirror. If we have a box, on one side of the mirror you would see reflected in the mirror the image of the box, which occurs because the light that is bouncing off the box is reflected off the mirror and received by your eye. This creates the image of the box in the mirror. This same phenomenon occurs in different materials. For instance, this Ferrari's window. If you see a reflection in a car's window, often you can see your reflection and the space beyond your reflection. This is because some of the light is reflected by the window while some passes through. We'll talk about this more in the next lecture when we cover refraction. Other types of waves also undergo reflection. For instance, this is a representation of a sound wave. A sound wave can similarly bounce off a surface, such as a wall, and become reflected, like this. It undergoes a change in direction. This is what happens when you hear an echo. Mechanical waves also undergo reflection. For instance, let's say we cause a disturbance in this rope by flicking it upwards, so we get a wave like this, which propagates in this direction along the rope. When the wave reaches this point, at which the thickness or the weight of the rope changes, it will become reflected. This is a key component of the theory of reflection. Reflection is a surface phenomenon, which means it occurs at the boundary between two different media, in this case between the thinner rope and the thicker rope. In this case, the difference in thickness between the two parts of the rope isn't so significant, so this means that some of the wave's energy will continue to propagate through the thicker part of the rope, while some of it will be reflected back. This is analogous to the way light behaves when it passes through a car's window. In the next lecture, I'll discuss what happens to the wave's energy which is not reflected.